So the first type of vectors we're going to study are called geometric vectors, which means we draw geometric pictures of them. Later on we'll do algebraic vectors where we do them without the drawings. But right now we're going to draw them. And all vectors are represented with arrows because we need a magnitude and a direction. So if I choose a vector like this, the length of the vector is called its magnitude, and of course the arrow itself describes the direction. This vector is obviously completely different than this vector, which represents a different scenario. One, because it's shorter, so it's not as big, and secondly, it has a different direction. We can label vectors either with just letters, for example, vector W, and we draw an arrow above it. You're actually supposed to draw a complete arrow on top and bottom, but mathematicians are lazy and only want to draw the top half, so you'll see that often it's just this symbol on top of the vector. And you can either use any letter, or you can use the endpoints of the vector. For example, if this is A and this is B, then we can describe this as vector AB, again with the symbol above it. So let's talk about equivalent vectors. Equivalent vectors, in order for them to be equivalent and exactly the same, they have to have both the same magnitude and direction. You may have ones that have the same magnitude, so they're the same length, but if they're in different directions, they're considered different vectors. And you can have vectors that are in the same direction, but not as long or longer. Those ones, again, are different vectors because they have different magnitudes. So let's look at a couple of examples here. So here I've got three vectors. The first one is AB because it goes from point A to B. Second one is CD, and the third one I'm calling BA. So the first question is, what do you think about AB and CD? They appear to be in the same direction and the same magnitude. Since I'm on the smartboard, I can check that by maybe cloning one and moving it over, seeing if it lines up. And you'll see that it's exactly the same in both direction and magnitude, so these must be the same. So then we can conclude that AB equals CD. They are equivalent vectors because they have the same magnitude and the same direction. But what about AB and BA? If you look at them, they appear to be very similar. They look like they're the same length, but of course there's one major difference. And that difference is that BA is going in an opposite direction. And so AB may be equal to CD, but AB is not equal to BA. Even though it has one of the characteristics that's the same, it has to have both of them. And so since the direction is opposite, they're not the same. You can say something about it though. You can say this, that AB is equal to negative BA. So because they have the same magnitude, then at least we know, but in opposite directions, the negative in front tells us we're going in the opposite direction. So if you take BA and put a negative in front of it, it's as if we're going from A to B. And that vector would be the same. Another piece of notation is this notation where we have, it looks like the absolute value bars of AB. This denotes that I'm only interested in the magnitude of AB. So I could write the vector AB, but if I put the absolute value bars around it, I don't care so much about its direction, I only care about its magnitude. So if I'm talking magnitudes, now I know that AB, CD, and BA are all the same magnitude. So what I can say is, this is true. vector AB, the magnitude of vector AB is the same as the magnitude of BA, even though AB itself does not equal BA because they have opposite directions.